thank you for the feedback, and we'll go ahead and get started. Let me move you guys back into view. Where are you at? There we are. All right, and right away into another possible technical interview question, right? What is a full stack application? So we'll define it and then we'll talk about what it does for us, right? Our typical kind of dissection. So Farhan, what is a full stack application?
A full stack application would have two sides, the front end and the back end. Uh, Front end, I would say, is more user centric and focused, whereas the back end is more server side focused.
Yeah, and we can diagram that out, right? So one of the sections is of front end would be the client, and the other section, the back end, one piece of it would be what we call the server. The other piece of the back end, which today we won't dissect as much, but definitely starting next week, is going to be the database. So I want you to think of these three parts when you're thinking about a full stack application. The kind of strange thing about where we're at now, and this is the first cohort where this is true, is that we're building the client and the server with the same technology, which kind of makes it hard to separate mentally in your mind. And what technology are we using to build both the client and the server, Victor?
Next.js.
Yeah, so we're using what's called Next.js. And at the end of the day, the client, the other technologies, Next.js is going to spit out some HTML, CSS, and JavaScript. So, and the server we're also going to build with Next.js. But at the end of the day, it's just going to be a running node application. But that part of it we're not really concerned with. What's going to feel real to us is the Next.js part. Because we're using this one technology to build both the server and the client, the distinction between front end and back end is going to feel harder to grasp. So in the past, you would use a whole different programming language to build your server, right? You might use C or Java or Ruby. Recently, you also would use JavaScript to build maybe a Node Express app. But now we're actually using the very same meta framework, Next.js, to build our server and our client. So the distinction between front end and back end is gonna at times be really hard to think about. But what you want to think is where is my JavaScript running? And if it's running on the client's computer, specifically the browser, then it's running on the front end, right? And if it's not, if the JavaScript is running on a different computer, then it's part of the server and the back end. So that's a little bit what is a full stack application. But now let's talk, why do we need a full stack application? So what have we built so far, right? Diary, Milkman, Hungry Pets, I don't know, a lot of different applications, right? Some of these even involved complex user interactions. So what's the rest of this course about? Why do we need a full stack application? Ellery?
We need a full stack because we need the server and the database. So we need to store information on the servers in the database.
Yeah.
So if you have like user login details, anything that you need to store
Yeah.
would go on the database.
Yeah. So I shouldn't even say store user info. Store info in the database, right? Particularly the info that is created with user interactions. Okay, so let's talk about that, right? So let's go to the big sites. And
in today's video,
it always defaults to this video. It's kind of annoying. So let's talk about YouTube, right? What is some interaction, user interaction, that YouTube might want to save when I interact with YouTube? David? Or yeah, Calypso?
Oh, sorry. I was gonna say like your watch history. It like keeps a
Yeah,
record of all the videos.
it definitely keeps track of my watch history. That's correct. So the JavaScript running on my browser right now has to send a request to the server. Hey, add this to his watch history. He just watched House of Dragon Season 2, a teaser. And that has to be recorded. What else, though? David, what's another example?
You'll want to save like how many likes and comments
and
playlists.
Yeah, I just liked Godzilla, so they need to record that because that like has to be seen by other users as well. So they have to save that in their database, the like. And maybe I made a comment on Godzilla, right? This is the best one yet or something. They have to save that comment because they want to show that to other users. So those are some interactions that need to be saved. There's a kind of a big one though, there's one big one of YouTube, right? What is the main thing that YouTube? What's its like? What?
Signing in.
Yeah, so I wanted to talk about that next, but we'll talk about that next. Signing in, but videos, right? Are what the bread and butter of YouTube. It's widgets. So users submit their videos. That's how YouTube functions. It's all user provided content. So they need to save those videos somewhere. Okay, what about Amazon, right? So what's this is a little bit less obvious, but what's some interactions here that Amazon needs a full stack application to function? Pimpa, what do you think? So what's user interaction that Amazon needs to save to its database?
The products?
Yeah, so possibly the typical user, we don't edit products, but there has to be some kind of other level of user where they have a company that sells products on Amazon and they have to have an interface for entering their product information. So yeah, absolutely. Or even internally in Amazon, the people who are entering product information are not going to be the ones who are designing the website. I'm sure that's different. So they need an interface to add products as well or edit them. What else? Izzy, what's some user interaction on Amazon that Amazon needs to save?
Purchase history?
Yeah. Amazon needs to record the purchases I make in case I want to return it return it. Daniel, what else from Amazon?
Has anybody mentioned like reviews and stuff?
Yeah, I want to leave a review on the Crocs, right? That they're really comfortable. So I need to send a request from my client to the server to save that in the database, that new review. Yep, those are all very good. So there's one other main component besides storing new info in the database. What about a site like Netflix, right? There's really not too much user interaction. Like I don't know. Can you even rate shows you've seen? I think you could in the past. I don't even know if you can right now. But Netflix absolutely has a server. So what's another category of things that we need full stack applications for?
The login?
Yeah. So the other kind of bucket or major purpose of full stack applications is authentication, which is going to be a huge topic for us in 2 weeks. We're going to actually create our own auth. So we're not going to rely on a package. So auth is going to be a huge topic for us. So we have a client and we have a server. These two you can think of as two independent applications. And then the question is, well, how do they request things from each other? Whoops. Right? So they need a language to talk to each other. Let's say we're Twitter, right? And our client's browser wants to request all the latest tweets from the server. How do they make that request? Opens the class.
They do a fetch?
Yeah, so we have a built-in tool here called fetch, where all you have to do is give it the address of the server and the endpoint. So in this case, it might be like /tweets or api.com Twitter /tweets. So this is how the client might request from the server to get the tweets. And then how might the server respond to this request? Opens the class.
So HTTP?
Yeah, so the agreed upon language for communication is called HTTP, Hypertext Transfer Protocol, right? But then more specifically, the data type that the server will respond in is called what?
Is it a post?
JSON?
Yeah, so this is actually called JSON, which will look to us as JavaScript developers like a JavaScript object. And you can think of it as that. It's fine for right now. And it will give us back something that probably looks like this. What looks to us like an object, but actually is JSON. And one of the properties is tweets, and another property might be success. True. But this is the only way the client and the server can talk to each other. So the client has to send this fetch request. And this type of request is called a GET request. There's different categories of HTTP requests that can be made. So this first one is a GET. So we're just retrieving tweets. Any questions on this first one? This is kind of the simplest of the requests a client can make to a server. Okay, but what's another type of request that can be made, right? So on Twitter, you can't, besides for just getting tweets, what else can you do? What else can you do to a tweet? Mehdi, what else can be done to a tweet?
I actually didn't fulfill the whole pre-workout.
Okay. Well, just like in Twitter, if you're separate from code or anything, if you're on Twitter, what can you do to a tweet?
I don't actually use Twitter too.
Okay. It's just like a message, but sure.
Message. We can send it then.
Yeah. So instead of getting all the latest tweets, what if we want to create a new tweet, right? So Thanks, Mehdi. So here, this isn't a GET request anymore. This type of request is called a POST request because we're asking the database to post something new. And we might still actually use this as our endpoint. But here now we need more information than just the endpoint we want to hit. What's the additional information that we might need? Whoops. With this fetch request for tweets. If we're asking the server to create a new tweet, what information do we have to provide to the server? Do we think? Yeah, Mehdi.
You have to tell it to get no.
Well, so we're not getting tweets anymore. We're trying to ask the server to create a new tweet. So we're sending our fetch request to /tweets and this method is a post request. Post something new to the database. Yeah, but what additional information do we probably need to send to the server? Zubida, what do you think?
I'm not certain.
Okay. Sadiq, what do you think?
ID?
Well, ID will actually always be or not always, but typically will be auto-generated on the database. But essentially a tweet is what?
String?
A string? Yeah, like a message, whatever we want to call it. Yeah, so I hated the new Godzilla, right? So that's my controversial tweet. So that's I have to send that to the server because they need to know how to create the tweet. This is very simplified, obviously, but what's some additional information the server also probably needs to know to create a new tweet in the database? Sadiq?
Content type?
Yeah, that's more homework that we have to provide with the fetch request. Yeah, correct. But I was thinking the actual to create like the actual tweet. What might the Twitter server need?
I'm not sure.
Open to class. Any ideas there?
Will it need like the user?
Yeah, it's going to need like the user information. I guess that's it, huh? For a tweet. Yeah.
Yeah, I think so.
Yeah, because the likes will be 0 at first and the retweets and everything. Yeah. So probably the message and which user created it will be what they need. And then what will be the response? The response will likely just be like the tweet and then a copy of the new tweet that was created. In this case, it will have an ID and a message, blah, 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 right? So that's a post request, but that's not all we can ask the server to do. What else can we ask the server to do? Yeah. What's another type of request possible? Client to server. Farhan? Farhan?
It's a put request. So instead of posting, it would be updating.
Yeah. So put is updating. So what if you wanted to edit a tweet, right? And in this week's project, you're going to do all these operations. It's referred to as CRUD is the acronym for create, read, update, delete. And you're going to have to do all these. But what would be a likely endpoint that we'd have to hit for this put request, Farhan?
Maybe the user?
So this could be anything. It's up to the backend developer, but likely this would be tweets and then like the tweet ID. So like this was tweet 23, right? And then they also need, so you're asking to edit this tweet. What other information do you need to send the server, Farhan?
So it would be the message that they're now
Yeah,
updating
so
it
the
to.
new message. I love Godzilla, actually. Yeah, so we got so much hate from hating Godzilla that we edited our tweet to say I love Godzilla. So they need that new message, right, to the server. Any questions on that? Okay, so that's a put request. And then we only have one major category left. So what else can we do to a tweet?
You can delete.
Yeah, good, Mehdi. We can delete. What would be the likely endpoint we'd have to hit to ask to delete? What do you think, Ketzerin?
ID.
Yeah, so it'd actually be this endpoint would be likely if they were following what's called REST protocol or standards. So it's how we name our path, basically. Do we need other information besides which ID of the tweet to delete? Does it need a body?
No.
Yeah, no. And then the response might be something like this. Yeah. The tweet that was deleted. That might be a likely response. Yeah. So those are all the different types of requests a client can make to a server. So this week you're going to do all these requests. But today, all we're going to do is GET requests. So there's servers out there. There's APIs, right? And all we're going to do is ask them for information. And that's all we're doing today, GET requests. So I thought we could use these for some practice today. So we have this Pokemon API. And here's the thing. When you're using someone else's API, you had nothing to do with writing it. So you have no idea how it's organized. So the document that you go to that tells you how to consume their API is called the API docs. And that's instructions how you, as the front-end developer, should ask the server for different things. So here are their API docs telling us how we can get information on a specific Pokemon. But also, I think we can I think if we just do /Pokemon, we can just get, some basic Pokemon. But there's a whole lot of information here. So our browser can do a GET request. So let's just plug this in, right? And press enter. And here's the response we get from the server. So the data type is JSON, but it looks like an object to us. And it has some different properties, but the one we care the most about is results. So this is how we can do this from the browser. But how can we do this from our code here, from our application? So I want to send a request to get some Pokemon from the code right here. So how can I do that?
You have to make a variable first.
Okay.
So const response is fine. And then equals await fetch.
Yeah, so we have this built-in function fetch, which is specifically for the client requesting things from a server, right? And the only argument it needs right now is the address of the server, which is the URL. So we can just plug that in right here. And then we can console.log the response. And if I run this Next.js app, we'll go ahead and see what's in our console. And what I get here is a response object. So when we see that, we basically have to know, this is kind of just homework. We have to convert this into an appropriate form for us. So what we want to do is convert this JSON to an object. So we need to do response.json. And then finally, we'll console.log this info after converting it. And now this looks like something we're more familiar with, right? So we have an object here with these properties. But what we're really after, let's actually say that my end goal for this application is to just have a list of these Pokemon. So Bulbasaur, Ivysaur, Charmander, and keep on going, right? So this is my goal for this application. So this is what I have so far from the server. But what I really want is that array of Pokemon. So using info, how can I save that array of Pokemon in a variable called Pokemon?
Info.result.
So it's going to be info.results is where that array is stored, right? And then I can console.log Pokemon. And now I just have the array of Pokemon. And then to display them down here, now that I have that array of Pokemon, how can I display them?
Map it.
Yeah. So we're going to go ahead and do Pokemon.map. We need to provide this with a callback function. And for every Pokemon, I'm just going to make a div with that Pokemon's name. And because I used map, I'm getting a warning that I need to provide it. Oh, am I not? Never mind. Okay, so we've requested from this API the Pokemon. We had to convert it from JSON to an object because we're using JavaScript. Someone else might be using Python. I saved the Pokemon in a variable called Pokemon by searching through the results. And then I mapped out here the different Pokemon. Any questions on that?
Is there a limit? Because there's definitely way more Pokemon than 20.
Yeah, I don't know how this server is deciding which Pokemon to provide. So you would have to read the docs here. Yeah. Berries here. Pokemon.
I think at the very top it mentioned something about 20 resources or something like that. Like in the very, very beginning of the doc. If you scroll down, like, oh, yeah, okay, will contain up to 20 resources.
Oh, okay. Oh, so you can give the server more information if you want more Pokemon. So here, using the query parameter, limit equals 100. Let's see if we can increase the number of Pokemon, right? So now back to our app. Now we have 100 Pokemon. Because we went to the docs and we saw how they decided we have to ask them for more Pokemon. And we have to, basically we have to follow their rules because they're the ones who created the server.
Max?
Yeah.
Why do you have a warning in your Node.js but not a warning in your browser?
So this gets complicated, but this component is actually running on the server. So Next.js is smart enough to know that the components that can run on the server should run on the server because it's less JavaScript you have to send to the client, and it's just quicker, less load on the client's machine. So unless we say here, use client, this is actually running on the server. So if it's deployed, it'll be running on Netlify's computer as opposed to your client's computer. And because it's running on the server, we see the message here in the terminal as opposed to the console in the browser. So I was looking for the warning here, but really it was here. So now I can put the key equals Pokemon.id right here.
So, Max, this is server to server communication we're doing?
Yeah, technically.
It's a client? Okay.
Yeah, I know that's confusing. I know that's very confusing. This is a very new idea, these server components. So if your mental model, you want to think of the components as running on the client, that's probably fine. But this is actually running on the server. So technically, this is one server requesting information from another server. Correct.
So in the pre-work, it talked about like when you fetch stuff, sometimes there's an infinite loop. Is there not that problem with this one?
There would be this problem if we were running this on the client.
Okay.
And maybe that's worth actually going through. So let's actually make this component run on the client, right? And then see what kind of problems that causes. So right away, we're not allowed to have oh, is this just?
There is no ID in the API.
There's
What?
I don't think that the Pokemon list have an ID. If you check on the documents.
No, you might want to put their index instead, maybe.
Oh,
they only
I'll
have
just
the name and the URL.
I'll just do the name. Let's assume the name is unique, right? So right away, we can't use async await as a client component. So we're not allowed to use this async anymore. So if this is running on the client, we really need to put this in a function that we would maybe call fetch Pokemon. So I'm going to move this code into here. And now I can make this an async function. And I'm also realizing we haven't touched on async yet. So let's spend a moment there, right? So what is async? We actually have touched on this a bit, right? And the easiest way to answer is what is async is what is synchronous. So what is synchronous code?
When it runs in order?
Yeah, it runs in order, top to bottom, and it waits for one line to finish. before another runs. So what's the problem with this? Actually, does anyone know? What would be the problem if all our code was just synchronous?
Is it too slow?
Yeah, there's some actions in JavaScript land that take way longer than others. And for those, we don't want to block all our code waiting for those slow actions. So imagine how bad a user experience would be if for 10 seconds the website just froze because it had to wait to do this one really long thing. And the slow actions in JavaScript, the slowest of actions are fetching from a server. So those we designate as async. And also reading from files, which we're not going to really do in this course. But this is like if you needed to read from like a text file into the code. And what else? There's another category that I'm forgetting right now. Somebody can maybe remind me of in a second. But the big one for today is fetching. So basically the way JavaScript was designed is let's make fetching run after all the synchronous code. Let's designate that as a special kind of process. And let's actually have the browser do that work. Let's offload it somewhere else. And let's have that not in our normal like synchronous running code. So fetching will always run after all synchronous code has run. And if code is async, like fetching, we will return a promise that basically will alert you when it's done running and has the info you need. So basically, when we use this fetch, it returns what's called a promise. Let's see if we can actually see that in... So I'm going to take away this keyword await. We'll talk about that in a second. And I'm just going to try to console.log this response. And for right now, I'll just comment this out. Okay, so now I defined this function, but to run it, I just need to run fetch Pokemon. And now I see that this function ran 2 times. And you see I have an object here with promise. So this is what we were talking about before, that fetching is async and it doesn't want to block all the code. So it returns to you this weird object called a promise. And it will alert you when it's done getting the information it needs to get, right? We have this keyword called await that lets us resolve the promise. So we go ahead and basically say, take all the time you need within this block of code and return to us the info we need. So now if we resolve this promise and look at the response, we can see we have this object that we need to convert from JSON to an object. So if I do response.json, the thing about this method is it returns another promise. So we have to again use await to tell it, take all the time you want, and I need the meat of what's returned after your work. And then finally, we have the info we're after from the server. The problem is now that we're doing this as a client request, what we really want to do is save this Pokemon in state. So we need a new piece of state called Pokemon and set Pokemon. And we'll import useState. And then here, we want to set Pokemon with info dot, what is it? So info dot results is the array of Pokemon.
Should we use optional chaining?
Should we use what?
Question mark. Info question mark dot result. Optional chaining.
You can if you want, but no, because basically so to be more careful, you could do if info dot results exists, then I want to set Pokemon, because there's a chance that this request will fail. So let's console.log Pokemon, see if that even worked, right? And look, what do we notice? I've created myself an infinite loop. Does anyone know why?
It's re-rendering the page over and over again.
Because
yeah, so we've created an infinite loop because we're running this function fetch Pokemon. It's requesting from the server the Pokemon. It's setting them in state. And then because it's setting them in state, what does React do?
It re-renders.
Yeah, it re-renders, and then this runs again, this fetch Pokemon. So to prevent this, something we have in React is called use effect hook, where specifically we can have a function just run one time. If we have an empty, what's called array dependency right here. So if I put fetch Pokemon here, this will only now run, twice because we're in development, but once in production. So it's a lot more work if we run this on the client to do a fetch request. It was easier using this as a server component, right? And today I think you can mostly do server components. There might be one or two that you have to do client because you have interactions, but I'm not positive about that. You might get away with doing all server components. Questions on that?
So we did like the server component like you did in the very beginning.
Mm-hmm.
Do we still need to, because I noticed right there like on line 19 const pokemon.info.results, would we still need to save that as state somewhere, or
No.
we just do it as a variable?
No, that's one of the beauties of the server components. Yeah, you don't need state. Yeah. If you need state, then it has to run on the client because state only exists in the client. Other questions?
So what was the reason why server doesn't particularly face the same issue as a client where it's re-rendering over and over infinitely? What was the reason again for server
Because on the server it's just running once. It's not running like a traditional React component. React components re-render because of state. And if a server component has no state, then it's not re-rendering. So there's nothing that's causing that server component, that React component, to re-render because state isn't changing. Any other questions? Okay. So I'll go ahead and open this up and get you into the rooms. More breakout rooms.